Okay, so in this video we're going to answer the question that we have on the screen, and this is just a trig substitution. We're given a substitution that we want to place into this expression, and so we want to simplify square root of a squared minus x squared. So in place of x, I'm simply going to put a sine theta. So in my expression that I'm given, I put a sine of theta, and that's all squared. Okay, so using my rules of exponents, I've got a squared and sine squared. All under the square root, and both of those terms have an a squared, so I can factor an a squared off. Okay, and from the identity that sine squared plus cosine squared equals 1, we know that 1 minus sine squared must be the same as cosine squared. So that's because of this identity. If I solve for cosine squared, I get 1 minus sine squared. So what I'm left with under my radical is a squared cosine squared. And if I take the square root of a squared, I get a. And if I take the square root of cosine squared, I get the cosine of theta. And I would normally need to make sure that I take the absolute value of this, because cosine of an angle could be positive or negative, and the same with a. However, we can alleviate that if we know at the beginning, which I should have written down and I forgot to, we have the assumptions that a is greater than 0 and that our angle is between 0 and pi over 2. So that would mean that a can't be negative, and if our angle is between 0 and pi over 2, then the cosine must also be positive, can't be negative. So there's our simplified version of the expression. And then we have this other part of the problem, which is to figure out the cosine of the angle and the tangent of the angle. And to do that, I'm going to use what was given, which is that x is equal to a sine theta. And I'm just going to solve that to tell me that the sine of theta must be x over a. And if I know that the sine of theta is x over a, I can make a little triangle. We knew, again, I forgot to write it at the beginning, but we knew that our angle is between 0 and 90. So it must look something like this. And opposite over hypotenuse is the sine. And so if I use my Pythagorean theorem, this side squared plus this side squared must equal this side squared, which tells me that this side, if you want to give this a name, b or something like that, you could figure out what b is. Let's see, Pythagorean theorem would be a squared equals x squared plus b squared. So solving for b, you would get the square root of a squared. Try that again. A squared minus x squared. So with that, we could get that the cosine of theta is b over a. So that would be this expression over a. And we could see that from our work, I think. I had this equivalency up here. That's equal to a cosine theta, so if I solve that for cosine of theta, I would get the same thing. And also I can get the tangent now. The tangent would be x over b, but again I know this is equivalent to b, so x over square root of a squared minus x squared. And another way I could have gotten the tangent is to take the sine of theta and divide it by the cosine of theta. Either way, you should get the same thing, and I think that completes this problem.